When looking to see if a function will increase or decrease, it is a key to look at the bases. To see if it is increasing, the base would have to be greater than 1. An example of that would be 2 to the x. The base is 2 and is greater than 1, so it's increasing. To know if it is decreasing, the base would be greater than 0 but less than 1. In the equation y equals 1/2 over x, the base is greater than 0 but less than 1. Next problem. When finding the domain, you have to take what's in the parentheses. So in this case, it would be 5x plus 3, and you would have to see if that is greater than 0. So you put 5x plus 3 is greater than 0, and then solve. So in this case, you move the -3 to the other side, and you get 5x is greater than -3. From there, you divide the 5 and get x is greater than -3 over 5. Since this is the case, that means that it will be going to positive infinity. So the domain would be -3 over 5 comma infinity. When finding the inverse, you switch the y and the x, and you get, and in this scenario, you get x equals ln open parentheses 5y plus 3 close parentheses. Then you subtract, then you make the ln, you move the ln to the other side to get e to the x equals 5y plus 3. Then you subtract 3 and get e to the x minus 3 equals 5y. After this, you divide 5 and get y equals e to the x over 5 minus 3 over 5. This would be the inverse. And from the inverse, you would get the range of this problem, which is open parentheses -3 over 5 comma infinity close parentheses. Next problem. So for my equation for this one, I did 6 log open parentheses x minus 2 close parentheses minus 7. To find the vertical asymptotes, you take x minus 2 and set that equal to 0 and solve, and you get 2. Now, by looking at this equation, we could tell that there is no horizontal or oblique asymptotes. So from there on, you would just plug in the x's, and that would give you the curve on the graph, and this is how you graph my problem. Thank you.